video, I will be explaining about why do we use reusable rockets? Why is it important that reusability is very important in space science? And I'm going to use the orbiter mechanics for explaining you. So now, why do we use reusable rockets? First, let me explain how does the basic rocket work. Basic rocket just moves with the propulsion. And after a stage, that is, let's say this is two-stage rocket, meaning that it can be separated twice times. Now here is this first stage, it's the topmost stage, and then here's a separation, and then here's another body tank, there's a fuel tank, and a main nozzle, which is for the ground stage. The rocket first at land. Now let me explain the basic rocket movement with this graph. This way is the distance covered and this way is the time taken. So let us say this red dot is the rocket, and at a time of, let's say, 5 seconds, it covers the distance of 2 kilometers. In 5 seconds it's going 2 kilometers. Let us say this is the maximum fuel length. This rocket is having a two-stage rocket, as I told you before. It will have a nose cone, a first body tank, a nozzle, another body tank, a separator in between, and then the main nozzle. So this first nozzle, which is this nozzle, after it empties, there is a fuel tank. The first, let's say this is 1. After this one empties, that is at the height of 2 kilometers and for a rate of 5 seconds. At this stage, the rocket will have zero propulsion, not zero propulsion. The rocket propulsion will be stopped. In that stage, let's say this is stage 1. In this stage, the rocket will lose this compartment, which is that the rocket will lose the compartment number 1. So this will fall down into the earth and crash somewhere in the Atlantic Ocean or anywhere. So this is a dump again. After this stage, this is the first stage, rocket will again climb up, let's say for orbiting maneuver, and the second stage, which is 2, will come in function here, and then the rocket will go onto orbit. So this is how a rocket mainly basically works from the first stage to second stage. And we basically use 2 stages rocket for going to orbiting maneuvers, delivering orbits to ISS and all those things. So here's a small thing. Let us say this rocket was a 3-stage rocket like this. A nozzle, a fuel, this is nozzle number 3, and a separator, another fuel tank, this is 2, a nozzle, another separator, and another more fuel tank, this is 1, and a nozzle. Let us say that the scenario for the first 2 stages are same like this, but a little lower, this area. From here, the second thing here, which is, but you have a case that the orbiting maneuver start from this area for this stage, 3-stage rocket. This is a 3-stage rocket, and this is a 2-stage rocket. So this 3-stage rocket will, in the second stage itself, will start its orbiting maneuver. And let's say at this point, this stage gets emptied. The second stage gets emptied too. Now what will happen? It is very crucial. Actually, the whole rocket itself is now orbiting the Earth. So if the second stage got separated on the orbit itself, it will revolve around the Earth, making space junk. Space junk is happening all around the world. If you launch a satellite, the big fuel tanks get released in space into its orbit itself and make a very dangerous issues. So after this, again, this second stage will get separated, and from there the third stage will get functional to wherever to go. So this stage is very crucial where we use reusable rockets. So how do we make a reusable rocket? We know the SpaceX, it is Falcon 9. SpaceX has made this Falcon 9, which is a fully reusable rocket. But what was the first reusable rocket? What was the first reusable rocket? Not fully, but nearly full reusable rocket. It was the space shuttle missions. Atlantis, Columbia, The space shuttle was like this. So now the space shuttle would be here, and then here will be a big fuel tank. The special landing legs will be inside, and then here will be a big fuel tank, and then here will be a nose cone, and two more strap-on boosters. Strap-on boosters means two side boosters like this. There will be a nose cone, one staged. Stages can be separated into vertical stages and horizontal stages. Stages can be put up like this, with the separators having a small explosive charges in these sides, and there will be side boosters which give force, and after the empty of side boosters they'll be removed, and then the main booster will start to act. Then the same technology is used here too. Now what happens is that the space shuttle, after the whole stage, this is the rocket stage, goes into space, into orbit, the space shuttle gets detached, meaning that it will get separated from this body tank. So we can say that the body tank will get separated from this space area. So there will be no more, the first thing will get separated, then the whole body itself gets separated, leaving a huge pile of junk into space. So then the space capsule or the space shuttle will go and attach with the International Space Station and do its job. And after returning, this rocket part, this is the whole space shuttle thing, can be reused, meaning that this has this rocket re-entry burning technology, and therefore can be reused for the re-entry burns and all those. So this can be used with that, and so it can be reused. But Elon Musk's SpaceX is totally, really, fully functional reusable rocket. So how does this SpaceX, there is a Falcon 9 work, let's call it F9. How does this Falcon 9 work? It actually has a payload for human and cargo holds. There is Dragon capsule, Dragon cargo, and Crew Dragon. And here's a really big fuel tank, which is a one stage. And then here is a nozzle and a landing legs fixed to it. These landing legs are for the re-landing purposes. So there is this seaports which are called as drone ships, and after delivering this payload, there's this area. This area gets separated, and this has a company's idea is that there will be the separation and there will be a controlling area, so the control will go throughout the rocket. This control will lead the rocket back to the drone ship. They call this a drone ship, will be floating on water, and this is a sea launch pad or a landing pad. And then after that, this rocket will, after delivering the payload, let's say the payload goes here, this rocket will come down and lands here. So as you can see, after the fuel of this rocket, which is shown here in these controls, turns over, there's ends, then the rocket cannot be reused. But the Falcon 9 SpaceX can be reused again and again, so that there can be a possibility of chance of avoiding the space junk. Let me show you the scenario of a rocket launching in space. After a pace, the fuel ends. The rocket has no other way to escape but to just crash onto the ground. It just crashed onto the ground and end its journey. So this is how basically a non-reusable rocket works, and it is really dangerous as space junk will be accumulating onto the orbit of Earth. So therefore, it is the best to use the reusable rockets such as the Falcon 9, and I hope you enjoy the video, and thanks for watching.